morning. Our lesson today, force and motion. Chapter 11, force and motion. Force, it is a push or pull. So any push or pull from one object to another. So this is a push and this is a pull. Many forces occur as one object touches another and another forces without object touch. We have to know the direction and the strength. The direction east, west, north, south, and the strength according to the magnitude or the amount of force. Measured in units, Newton or pound, but the famous one is Newton. Forces can crush, stretch, or twist objects and deform them. Example, we can crush aluminum can if you squeeze it hard. So when you squeeze it hard, you'll find you can crush it. You need more force to change the shape of hard objects. The force can start moving, speed up or increase the speed, change direction, slow down, stop, and accelerate objects. The gravity. The forces that attract all the matter together. The Newton's law of universal gravitation. Isaac Newton, this is a scientist, believed that every object in the universe was pulling on every other object, like the Earth. The Earth attracts the Moon, and also the Sun can attract the Earth and all the planets around it in fixed orbit, as you know. The gravity depends on the mass of the object and the distance between them. So there is a directly proportional between the mass and the gravitational force. When the mass increases, the gravitational force or the gravity force increases. If the mass increases, the force increases. And if the distance increases, the force decreases. So when the distance increases, the force decreases. This is an inverse relation or inverse proportional. The force of gravity between the Earth and the Moon is 200 billion Newton. Friction. The force that opposes the motion of one object moving past another. So you will find the direction of the pole in the right, and you will find the friction in the left. So this is the opposite direction. And also here, the pushing force here and the friction in the opposite direction. Friction depends on the surface of the two objects. Smooth surfaces has less friction than the rough one. So when you rule the metallic ball on the ice surface or the glass surface, you will find it move long distance with a long time. But also, when you rule this ball on the rough surface, you will find it's just to move short distance and also in short time. How hard objects are pushed together? If the press increases, the friction increases. And also, if the weight increases, the friction increases. The friction between your hands generates heat. So when you rub your hand, you will find you will feel warm. Why? According to the friction generates heat. And the kinetic energy changes into heat energy. Air resistance. When the object moves through the air hits the object and slows it down. So the pilot here feel the air resistance affect the plane, and also here the air resistance to protect the man to hit the earth with a very high speed. And when the velocity increased, the air resistance increased. Also, there is a directly proportional between them or direct relation between them. What about the direct relation or directly proportional? It is a relation between two amounts. If the first increases, the second increases. And if the first decreases, the second decreases. And what about the inverse relation or inverse proportional? Also, this is a relationship between two amounts. When the first increases, you will find the second decreases, or vice versa. Also, liquid also exert resistance, so you will feel water resistance if you swim on the water, in the water. And also this boat, if the driver just stop press on the accelerate, so you will find the boat will slow down and decrease speed and stop. Why? According to the water resistance. This is why water can slow down a boat. Newton's law. Newton's first law, balanced force. A force acts on the object without changing its motion. So you'll find the object at rest or constant. Unbalanced force, a force that causes an object to change its motion. So this metallic pole, just when it struck this pole, you'll find it move and it change its position and it change its motion. This is scientist Isaac Newton who discovered the gravity. The Newton's first law, the law of inertia. You know, inertia is the tendency of the object to keep its state. An object at rest tends to stay at rest, and an object in constant motion tends to stay in motion unless acted upon by an unbalanced force. So when you inside the car and the driver started to move suddenly, you will find you rush backward. Why? Because your body try to keep your state of rest. And also, if you inside the moving car and the driver stops suddenly, you will find you rush forward. Why? Because also your body wanted to keep its state of moving. Newton's second law, the unbalanced forces on the object is equal to the mass of the object multiplied by its acceleration. So two factors here, the mass and the acceleration. When the acceleration increases, the forces increases. So you will find this also direct relation between them. This law is called the law of acceleration. Force equal mass times acceleration. What about the problem? Calculating acceleration. Total force equal 80 Newton. Mass of boat equal 160 kilogram. The answer, force equal mass times acceleration. But now I want to calculate the acceleration. So when you want to calculate the acceleration, well, the law become force divided by mass. So acceleration equal force divided by mass. Acceleration equal 80 divided by 160 equal half or 0.5 meter per second, or you can say meter per square second. Newton's third law, action and reaction. All forces occur in pairs, and these two forces are equal in strength and opposite in direction. So equal in amount, but opposite direction. For every action force, there is an equal and opposite reaction force. When one object pushes another one, the second pushes the first with the same strength. So when you blow the balloon and just leave it, you will find the air rush down and the balloon just rush up according to the action and reaction. Equal in amount but in opposite in direction. And also when you press by your finger in the wall, you will find also this is the action force by your finger, and the wall will exert another force equal in amount, equal in magnitude, but in opposite direction. So this is the action and this is the reaction. And also when you hammer a piece of metal, you will find this is the action by hammer, and the metal will exert another force equal in amount or equal in magnitude, but in opposite direction. This is called reaction force. So the push of the first is called the action force, and the push of the second is called reaction. Thank you and goodbye.